Hello students, now let's see the axonometric projection. Now, what does its definition? Axonometric projection is an orthographic projection in which at least three faces of the object are visible. It is constructed using translation, rotations and orthographic projection. Okay. Center of projection is at infinity. Center of projection is at infinity. Projectors are parallel and they make angle 90 degree with plane of projection. The lines which are not parallel with the plane of projection, the lines which are not parallel with the plane of projection are foreshortened. And that foreshortened factor is what does that foreshortening factor is? What projected length upon actual length. Projected length upon actual length is the foreshortening factor here. Now here, for example, or let me explain it diagrammatically. What does it exactly? It will be, suppose here this is a plane of projection. This is what? A plane of projection. This is our plane of projection. Okay. Here, suppose these are projectors. Now here, this is our line segment AB. That one we have to project on this plane. Then it will be projected as such, because this is two-dimensional plane, right? So it will be projected here. These are what? Projectors. Now this will be projected as A dash and it will be B dash. So this is our projection here. So this A dash B dash is what? Projection of projection of this AB, projection of AB. Therefore, what is F? F is A dash B dash upon what? AB, length of them. Okay. Also, in axonometric projection, in axonometric projections, this 0 less equal F less equal what? 1. This F, foreshortening factor, always lies between 0 to 1, or it may be 0 or it may be 1. Fine. Now, let's write the principal foreshortening factors. Principal foreshortening factors along XYZ axis are Fx, Fy and Fz. Fx, Fy, Fz respectively. These are these one. Fx, Fy, Fz respectively. Now, according to that, this axonometric projection is classified. Okay. Now we know axonometric projection has 3 different types, that is trimetric, diametric and isometric. So how does that? Let us see that one. The 3 axonometric projections are, they are what? First, trimetric. In trimetric axonometric projection, Fx not equal to Fy not equal to Fz. All are different. Okay. Second, diametric. In diametric, Fx equal to Fy, and that is not equal to what? Fz. Fx equal to Fy not equal to Fz. Both are equal. Third one is not same one, that like that. Third, then isometric. Isometric, what does it is? Fx equal to Fy equal to what? Fz. These one. Now, according to the values of these principal foreshortening factors along XYZ axis, the 3 types of axonometric projections are here: trimetric, diametric and isometric. Now the matrix for axonometric projection is the matrix for axonometric projection is T equal to, what does that T? That is x1, y1, 0, 0, x2, y2, 0, 0, x3, y3, 0, 0, x4, y4, 0, 0. This is a matrix for axonometric projection. And from that, what we get? Fx. What is Fx? Fx is nothing but under root x1 square plus y1 square. Then Fy is under root what? X2 square plus y2 square. And Fz is what? Under root x3 square plus y3 square. This is our foreshortening factors. Okay. Now let us see one by one the trimetric, diametric and isometric. Now first trimetric axonometric projection. Trimetric axonometric projection. A standard trimetric projection is obtained by first rotating about y-axis through an angle phi, followed by rotation about x-axis through an angle theta, followed by orthographic projection on z equal to 0 plane. Therefore, the transformation matrix for trimetric projection is T equal to what? Rotation through y through an angle phi, right? Rotation about x through an angle theta, and what? Orthographic projection on z equal to 0 plane, on xy plane, right? Therefore, this T, what does this T? It is cos phi 0 minus sin phi 0, 0, 1, 0, 0. Then sin phi 0, cos phi 0, 0, 0, 0, 1. Then further 1, 0, 0, 0, 0, cos theta, sin theta 0, 0, minus sin theta, cos theta 0, 0, 0, 0, 1 into pz. So 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. This one. Okay. Now the product of these three will give us cos of phi, sin phi, sin theta 0, 0. Okay. 0, cos theta 0, 0. Then sin phi minus cos phi sin theta 0, 0 and 0, 0, 0, 1. This is a matrix for transformation where fx square equal to cos square phi plus sin square phi into sin square theta, Fy is what? Simply cos square theta. Fy square is that. It is in a square root. Fx, you know, Fx is what? Under root x1 square plus y1 square. Right? Therefore, squaring on both sides, square root is get removed. So, square root is removed. That's why fx square. x1 is what here? Cos phi. So, cos square phi. And y1 is what? Sin phi sin theta. If we compare with the matrix for axonometric projection. So, from that, this is y1. This is x2, y2. And x3, y3. So, let us write fy square is what? x2 is 0. So, plus y2 square is what? Cos square theta. As such. Fy is what? Root x2 square plus y2 square. And fz is what? Root x3 square plus y3 square. This is the part, right? Okay, and fz square is what? Sin square phi plus cos square phi into sin square theta. Call this as equation number 1. We will be naming it as equation number 1. Now, observe all these are what? Different. So, this is a matrix for trimetric axonometric projection. Now, the second one what? Diametric axonometric projection. Diametric axonometric projection. Okay. Axonometric projection in which two of the three foreshortening factors are equal. Two of the three foreshortening factors are equal. Say fx equal to fy. And third, say fz is called diametric projection. Diametric projection. Now, fx equal to fy implies fx square equal to fy square. Therefore, from 1 what we get? Cos square phi plus sin square phi into sin square theta equal to what? Cos square theta. Here this is equation 1. These are the foreshortening factors. So fx square equal to fy square. So these are equal, right? So now here this cos square phi can be written as 1 minus sin square phi, right? Plus sin square phi into sin square theta. And this cos square theta is 1 minus sin square theta. Okay. Therefore, now here these ones are get cancelled. We can remove them. Okay. Now here let us take this 1 and 1 cancelled. Now let us take minus sin square phi common. Minus sin square phi will be common. What is left here? 1. Here minus sin square theta is there. Okay. And here minus sin square theta as it is. This minus sign we can remove from both sides. So what does it gives? It gives sine square phi is what? Sine square theta upon 1 minus sine square theta. This one we can write. Call it as equation number 2. Sine square phi is sine square theta upon 1 minus sine square theta. Okay. Now by equation 1, what is fz square? Fz square is what? Sine square phi plus cos square phi into sine square theta. So it is sine square phi plus 1 minus sine square phi into sine square theta. You know sine square phi from equation 2, what is its value? Its value is sine square theta upon 1 minus sine square theta plus here 1 minus sine square theta upon 1 minus sine square theta into sine square theta from 2. Okay. Now we can easily simplify it. It is sine square theta upon 1 minus sine square theta plus 1 minus 2 sine square theta upon 1 minus sine square theta into sine square theta. Simplifying this one simply. Now let us take denominator common, 1 minus sine square theta. What is here? It will be sine square theta plus sine square theta minus 2 sine raised to 4 theta. So it will be 2 sine square theta minus 2 sine raised to 4 theta upon 1 minus sine square theta. So it is 2 sine square theta. So 1 minus sine square theta upon 1 minus sine square theta. This one. Okay. Now here these are get cancelled. So what we get? Fz square is equal to 2 sine square theta. Therefore sine square theta equal to Fz square upon 2. That gives sine theta equal to plus minus Fz upon root 2. Call it as equation number 3. And this one we will name as star. Okay. Now using 3 and 2, using 3 in 2. What is 2? 2 says sine square phi is what? Sine square theta upon 1 minus sine square theta. But from 3, what is sine theta? Fz upon root 2, or sine square theta is what? This one. Okay. So let's put that value. It is Fz square by 2 upon 1 minus Fz square by 2. So this will become Fz square upon 2 minus Fz square. Therefore this is what? Sine square phi. Simplification, right? Therefore sine phi, what is sine phi? Plus minus Fz upon root 2 minus fz square. This is the answer for what? Sin phi. Call it as equation number 4. Given value of foreshortening factor fz along z-axis gives theta equal to, what is theta from this? Theta equal to what? Sin inverse of plus minus fz upon root 2 and phi equal to sin inverse of this plus minus fz upon root 2 minus fz square, this one. Okay, now from this we get 4 diametric projections. Therefore we get 4 diametric projections as first theta positive, phi positive. Second, theta positive, phi negative. Third, theta negative, phi positive. And fourth, theta negative and phi also negative. Now third thing, isometric, axonometric projection. Third, axonometric projection. So axonometric projection in which all 3 foreshortening factors are equal, that is fx equal to fy equal to fz, okay, is called isometric projection. Okay, now fy equal to fz, that gives fy square equal to fz square. So that gives cos square theta equal to 2 sin square theta by star. Cos square theta equal to 2 sin square theta by star, because from star fz square is equal to 2 sin square theta, and from 1 fy square is what? Cos square theta. So this gives 1 minus sin square theta equal to 2 sin square theta, because cos square theta is 1 minus sin square theta. So that gives 1 equal to 3 sin square theta. Therefore sin square theta is equal to what? 1 upon 3. That gives sin theta is equal to plus minus 1 upon root 3. Plus minus 1 by root 3. Therefore theta equal to plus minus sin sine inverse of 1 by root 3, and that is theta equal to plus minus 35.26 degree. This is theta for isometric projection. Put sine square theta equal to 1 by 3 in 2. What does it gives? It gives sine square phi is equal to 1 by 3 upon 1 minus 1 by 3. Okay, so that is, it will be 1 by 2. 1 by 2. This gives sine phi is equal to plus minus 1 upon root 2. That is, phi equal to plus minus sine inverse of 1 by root 2. Therefore, phi equal to plus minus 45 degree. This is the angle for isometric axonometric projection. Now, remember this, for trimetric axonometric projection, these are the four shortening factors. That is equation 1. From that one itself we have been deduced these sine square phi for axonometric projection. Actually, here we have sin theta is plus minus fz by root 2, sin phi is plus minus fz upon 2 minus fz square. So, if we know fz, from that we can easily determine theta and phi for diametric, right? And from that we get 4 different types of diametric projections according to the values of theta and phi. And for isometric axonometric projection, the angle theta and phi are fixed. That one we have been obtained from the given condition itself. So, these are the values for theta and phi for that. Okay. So, here we will stop for this video. In next video, we will see examples only. Thank you.